Cooperative Extension, and I'd like to welcome you all to our brown bag lunch on current research in forest science. We've got about 135 people signed on right now, so this is a tremendous sign-up. We're very, very pleased by this. One of our goals for doing this was to provide an opportunity to link the research that goes on in the University of California with practitioners out throughout actually the entire nation. We have people signed on from, I see people from Oregon, Washington, we have some people from Florida. So we're very excited about that. This is the very first of 6 sessions that will be coming up monthly, and I think you all had a chance to see the full slate of presentations that will be taking place over the course of this semester. Since it's a course kind of out of Berkeley, we usually start our classes at 12:10, but most of you start your life on the hour, so we split the difference and we started at 12:05. So that was one of the reasons we're getting started at this time. Just a couple of logistics before I turn it over to Susie Coker, who will give you a few more logistics. Wanted to let you know that this program has been approved for continuing education credits by both the Society of American Foresters. It has Category 1 CFE credits, and the International Society of Arboriculture. So both organizations have approved this program for continuing education credits. The other item is this is being recorded, so we'll have an opportunity for people that aren't able to participate to go back and to listen to the presentation. So we'll be sending that link out. And if any of you want to go back and re-listen to parts of the presentation, you'll be able to do that. Or if you want to forward the link to one of your colleagues, that would be fine as well. Ultimately, these will be posted in a YouTube format on the Center for Forestry website. So with that general welcome, I'm going to turn it over to Susie Coker. Susie is our natural resource advisor, forestry advisor in the Central Sierra Nevada, and has a lot of experience with the logistics of running webinars. So I'm going to turn it over to Susie to give you some additional information and to introduce our speaker. So Susie?
Hi, thanks Rick, and thanks everyone for turning out. I am really excited that it seems we have a great mix of speakers and topics that a lot of people are interested in, and I know that you're going to enjoy this talk today. As for how to participate, you'll be listening to everything going on through your speakers. If you have a question for the presenter, please go ahead and type it in the chat box as it occurs to you. I will be copying your questions, and we'll have our speaker answer them at the end. We are officially going till 1 o'clock. We'll let everybody go then. If we have a few extra questions afterwards, we can hold on a little bit longer for those who want to stay over. As far as sound, I'm not getting any feedback that the sound isn't good, but I would suggest that I can't make the verbal part as loud as the music, so if it now sounds too quiet, go ahead and turn your speakers up a little bit. If you are getting echoes, and I think there could be some that are because I see your name in twice, it's because you've logged on twice. You need to close out of one of your sessions. The reason you hear it, the echo, is that it's coming through a couple of times. I think that's it for now, and with that I'm going to go ahead and introduce our speaker, Dr. Scott Stevens, who's a professor of wildfire science at the University of California, Berkeley. He's going to be talking to us about fuels treatment effectiveness and how we're doing in the Sierra Nevada. So Scott, are you there?
I am.
Okay, I have a little feedback from people online that says it's not very loud, so if you could just speak up as much as you can, Scott, and go ahead.
Well, thanks, Susie and Rick. Hopefully this is loud enough. I can certainly increase volume here a little bit if you want. I'm thrilled to do this. I'm always happy to talk with people about natural sciences. the last time I gave a webinar here at Berkeley, we had a small earthquake of all crazy things. So we'll have to see. Hopefully it doesn't happen today. It wasn't one that was big, but I remember doing it because all of a sudden the whole office started to shake. So today I want to talk about the ecological effects of fuel treatments and then also some information about how we're doing in the Sierra Nevada. And I wanted to talk about this because it's a couple new papers that we've actually come out with, and I think Susie even provided those as PDFs to the webinar, which is great. So I first wanted to focus on a summary of what fire did in California before 1800. And here, this I think always is a benchmark because, you know, we see so much press about how fire is going bizarre. Things are burning up like crazy and a lot of notoriety, and we get good research that is pointing out that maybe the trend is increasing in wildland fire. And all that certainly is important, but I always like to ground this in maybe what happened in the past. And this helps us kind of think also just get a footing of what fire used to do. And then we're going to discuss this ecological impacts of fuel treatments. We had a bioscience paper come out recently to try to summarize that, and we're actually going to talk about the results of that. And then what kind of things can actually be done to enhance forest restoration in a context of reducing fire hazards. So we'll talk about that as well. So the first piece I wanted to chat about is this notion of what fire did in California. And what we did is in 2007, we actually wrote a paper trying to summarize what we thought fire once did pre-1800. 1800 was a bit of an arbitrary date. We just thought it was before a lot of Euro-American impacts. And we went to the literature. There was no real new research here. It was all based on literature that had been published. And we summarized the fire history literature based on tree rings. And we also summarized the Native American use of fire literature, which was much more profound in things like savannas, wetlands, and grasslands. And we don't have tree ring records there, so we had to go to a different source. And then once we had an idea of what fire was doing, we then looked at the kind of range of vegetation types in the state, and then came up with an estimate of what fire was once doing. So this is kind of the punchline. So the punchline here for the area we call California, the paper estimated that approximately 6 million acres burned annually. 6 million. This is a big number, right? This is a number that in some ways I think gets people kind of shocked because California we know is 100 million acres. 1/4 of California is desert, the Mojave Desert. We didn't know what fire was actually doing down there very much. There's very little literature. So we took that completely out of the analysis. So really, we're talking about 6 million acres burning in a land base of around 75 million acres. And if you look at what that compares to, that's about 90% of the annual area burned from 94 to 2004 in the entire United States. So roughly, California is burning in prehistoric context, almost what the United States is burning annually. And certainly those numbers have trended up a little bit since 2004. I'm sure they would be a little higher. But if you look at a record from 1950 to 99, Dave Sapsis and CAL FIRE folks helped me with that data, we see on average California burns around 6% of what it did pre-1800. And by no means is that pre-1800 number, absolutely solid. I would say, though, based on the paper, if you take a look at it, it's a conservative estimate. We're not talking about a crazy estimate. This is actually pretty darn conservative based on the intervals that we actually used in that paper. So I think that just gives us context, what fire used to do. Some of you may be hearing me call California not the Golden State. I call California the Pyro State. There was so much fire in this land that was so integral to the ecology at one time. And today we see very little of it. So when you see things like fires going up, and certainly it is maybe in the last 10 or 15 years, it's still a tiny number compared to what it used to do. I think that just gives us a little context. Now if we jump just to forest, the previous slide was all ecosystems. So this part of the presentation we'll talk just about forest. So here we actually estimate around 1 million acres burned annually in California on a typical year. So again, 1 million acres, that's a big number. June 2008, probably a lot of you think about June 2008. We had all those lightning fires come through, burned for a long time, smoked out a lot of areas. That turned out to be pretty darn close to what we think maybe area burned in forest was pre-1800. By no means is that something that's desirable in all years. I wouldn't say it is, but I just want to, again, give some context. And I think some of those June 2008 fires actually did a lot of ecological work. But there's no doubt there's also challenges with people, homes, smoke management, all that. So, but again, that just gives us a little context. So what about change in forest? And here's a couple of pictures I like to show now. These are from the Plumas National Forest, Bear Creek Guard Station. Maybe some of you have seen these. The district and the forest up there has shown these, I think, in a number of settings. Here's a picture of Walter Robertson, one of the first forest guards up there. It's close to UC Berkeley Forestry Camp, so people have gone up there for years. But you can see 1915, what do you see? A nice little cabin. And then you see kind of the context of the forest around it. A lot of ponderosa pine, pretty big trees, awful lot of open areas, shrublands in between. And by no means can we say this is going to be representative of everything. This is a picture of one place. But still, I think just a picture of 1,000 words, you can just see how much that forest is. You know, you got big trees and you got a lot of spacing. The next picture is going to be the same cabin about 90 years later. So we want context. And there's the same cabin. To the left, you see those big ponderosa pines. They actually are the same trees that were in the previous. So here you can see that there's the big trees. I'll turn on a little pointer just for a minute. And you can see that we have these trees in the background, which are big ponderosa pine. And then if we go to the next picture, you'll see those same trees essentially are standing there. Those are them. There's no doubt. You can see their morphology, and that's the same context. But we see an awful lot of white fir. Ryan Tompkins, I believe, took this picture from the Plumas. And again, this is an amazing change. I think so many times people will see a forest like that, multi-canopy, high canopy cover, a lot of green needles, and they think, oh my gosh, this is a beautiful old-growth forest. I have to say it's a giant artifact. It's an artifact of really land management in the last 100 years or so. We can't get much data from this picture, but what about some real data on forest conditions in the past? Well, here is actually a study that we began. Brandon Collins from the Forest Service Research Station, PSW in Davis, was the lead on this. And this is a copy of an early forest inventory sheet that was done in 1911 there in the central Sierra Nevada. It included about 1/3 of the area inventoried was now in Yosemite National Park and 2/3 to the west out in the Stanislaus National Forest. And we were fortunate enough to actually find copies of the original data sheets that were collected in 1911. These are actually referenced to the survey system, so our section corners. So you can go back to those section corners and do a sample to get an idea maybe of what has happened in the last roughly 100 years. Can't go back to the exact same place, but since the section corners are been there for pretty much 100 years, you can go back and get, I think, information really close to the original. So this is just a copy of one of the original data sheets. The next picture, what this is actually part of Yosemite. So up on the upper left, you can see a map of California, the Sierra Nevada gray, and then Yosemite National Park is black. And then what we have here is a piece of Yosemite. Yosemite is the boundary is the black and white line to the left. You see some polygons, a different color in there. Those are actually fires in Yosemite National Park. Some of them are lightning-ignited fires, others are prescribed fires. So that's the map that we're basically going to talk about for a moment. What's popped up now is actually a piece of information of the survey. You see that there might be a little information on a line that's coming up here. You see the line, my little arrow is moving down this line. So this is a blow-up of that little area up there to the dead center in the top. There's my little arrow on top. What that is an area where the 1911 survey happened. And each of the survey areas was something called a lot. A lot was a 10% sample of a strip cruise that was 2 chains wide and went along those corners of the early survey. We went out to these sites a few years ago and actually re-measured some of the trees. And instead of actually trying to get an inventory of the entire lot, the entire giant triangle, we subsamples. And you see inside there that there's some small circles. Those small circles, I'll point to them. These are basically places where we actually did a survey, just a circular plot, to give us an idea of what forest conditions today were. So we tried to compare the original area that was really a survey between a long transect versus several circular plots. The other thing that's in there as well is you see different colors. You see green, you see yellow, and you see a little bit of red. The green essentially is telling us that forest change there was very, very low severity in terms of the fires that burned in the site. The yellow is moderate severity. You see the legend on the bottom there maybe. And the red is the high severity areas. So these are classifications based on remote sensing trying to tell us about what fire severity has been in the recent fires. So it gives us an idea of the recent fire effects. So from that, we're going to talk a moment about what's happened in these areas. I wanted to show a couple slides with data, not too many, but here's one that I wanted to show you. And what we see is on the left, upper, we have data on tree sizes, and these are in centimeters, diameter in centimeters. So we have different size classes. You see them up there. And what we have is a 1911 versus their more recent area. So my little arrow now points to the 1911 tree density. So the tree density, 1911, and you can see that stacked, the little graph is stacked based on the size of the trees. But take a look at the 1911 density. These are in stems per hectare, 1911. And then in 2007, 2005, 2007, there it is. That's what we measured based on our subsamples. So an enormous increase in density. We've all heard this before, and we realize that forest has changed. This is an area inside Yosemite National Park. Originally, Yosemite was smaller than it is today. So this is an area that actually was originally in the Stanislaus. That's why it was actually inventoried by the Forest Service. And then later in the 1930s, Yosemite got bigger and jumped over the top of it. So these are areas essentially that have never been cut. So there's been no cutting here, but there has been certainly fire management, fire exclusion. So to the right side, we start to look at some more information on different types of fire severity. So down here at the bottom, modern fire group. We see no fire, we see low severity fire, and then we see moderate severity fire. It turns out we had very, very little information from our current fire regime that was in high severity. So the areas that burned at high severity, we can't really talk about. We can talk about the low, medium, and the high, moderate, because of just fortuitously, they actually had plots in those areas. So now we go up to the top and we see that in 1911, there's the original density, and the areas that had no fire in the preceding 100 years or so, density is really high, and we see a significant difference. What about in the low severity category? Again, we start out with a very low density of trees in 1911 based on the inventory, and places that had burned under low severity regime, we see that there actually is a reduction in density from the unburned area, but still much higher than the control or the 1911. And lastly, out here in the far right, 1911 density, roughly around 100, maybe 75, and then on to the right side, we see still a little higher, but no significant difference. So one thing this tells us is, at least in this example, we see that density starts to approach quote-unquote historical conditions with moderate severity fire, but we don't actually approach it as well with low severity, and then certainly the unburned case, we have a great number of trees. What about down below, derived canopy cover? So they didn't measure canopy cover in 1911, but you can use FVS in a tree list to give an estimate of canopy cover based on a tree list. So that's what's done here. So again, for the no fire area, we see canopy cover is estimated on the order of maybe around 20%, and up here with the no fire in 2005, 2007, we got canopy cover around 50. So again, changes in canopy cover quite dramatic. But look over there in the far right condition again. The far right shows that if we have canopy cover in 1911 approaching maybe 20, 25%, canopy cover of the same areas burned with moderate severity, we're getting around 25 to 27%, no change. So one thing I think this tells us is we can see kind of reductions in forest density and canopy cover begins to approach what was measured here in 1911 with really a moderate severity fire regime working on this site. Let's take a look at the next piece of information. Over here on the top right, we see basal area proportion based on species. I won't talk about that to save a little time. Down there in the bottom right, you see live carbon. So here's an area where we're trying to estimate carbon. And not surprising, you can see from the 1911 area with no burning, we got around 75 megagrams per hectare. Areas that had the same area in 1911 that had no fire for almost 100 years, we go up to 225. And to the right, we see that when it burns with moderate severity, that the carbon levels approach what they were in 1911. So this is, I think it's kind of interesting. One thing it does, to me at least, is show some evidence of forest conditions in the early 1900s. And frankly, the densities here and the canopy covers are even lower than I ever would have perceived. This is actually somewhat startling in some ways. I mean, you're talking about canopy covers on the average of 25 to 30%, and this is mixed conifer, high site, ponderosa pine, sugar pine, white fir, incense cedar. This is really some prime land on the west side. So we're talking about forests that grow a lot of trees and have the potential to produce a lot of biomass. But here in 1911, evidence shows that we're seeing densities much lower than I thought, that I would even guess, and canopy covers on the order of around 30%. So again, I think it just gives us an We know we're headed to changing climate, warmer conditions. Many of these forests all regenerated in the little ice age. But it still gives us an idea, I think, of just the resiliency of these systems and some idea of what the forests were before great management inputs. So management response, we know that we do fuel treatments, reduction in surface fuels and ladder fuel. Jim Agee and Carl Skinner wrote a nice paper in 2005. We know those are really important. If you want to reduce fire hazards, you're really after the surface fuels followed by the ladder fuels. But if you're also interested maybe in doing restoration, you find out that treating the surface fuels alone, you probably can do more change in restoration treatments where you maybe want to generate bigger gaps, more spacing, less crown cover. These are basically from the 1911 study show us that they're really important, that we don't have a lot of evidence in that study of a lot of areas, 50, 60% canopy cover, high basal areas, lots of multi-story canopy. We have very little evidence of that. In fact, we actually got a little bit more funding to expand this study. And this year, we're actually going to move into the Stanislaus and actually measure 2 times the area in the Stanislaus where we have the same data for and continue the comparison. So that's something we're a little excited about. But we do know that forest conditions are changed, and we have things like fuel treatments. Pete Fulet did a nice research article in 2012 where he actually summarized the effectiveness of fuel treatments. And just like Agee and Skinner, we find that they're quite effective. But I would say the caveat would be if you're interested in fuels, you're really after the surface fuel and the ladder fuel. If you're interested more in a restoration, kind of a restoration of ecosystem structure, potentially probably more resiliency in the future, I think the 1911 data helps us understand what that restoration might include. And it probably doesn't include the canopy covers we're actually seeing today. A couple pictures about restoration and fire. This is Blodgett Forest, UC Blodgett Forest out there in Georgetown. This is the fire and fire surrogate study. I just want to show a couple pictures on this. This is an area that had been commercially thinned from below about 3 times since 1970. Railroad logged about 1912, 1913. Before that, regenerated completely naturally without any planting. If you do an analysis here with some modeling, you come up with a torching index. The torching index is the theoretical wind speed to move the fire from the surface layer up into the canopy. 22 kilometers an hour under a day of typical weather in the summer. 22 kilometers an hour is pretty modest wind, so this one becomes then quite vulnerable to actual extreme fire behavior and effects. Then the next picture I'll just show is the mechanical treatment that we did. Here we did a 2-phase thinning treatment, thinning from below, both crown thinning to actually reduce crown cover and also to get the intermediate sized trees out. All activity fuels laid on the site. You can see a lot of it laying there. There's an awful lot of dead branches. We didn't have a bio facility that we could transport to and range economically. But here you see the torching index actually goes up to 52. And we know that increasing torching index is a desirable thing because we want higher wind speeds to initiate torching events. So the mechanical treatment alone actually does a pretty good job of reducing torching index. I don't have a picture of increasing torching index, I'm sorry, but I don't have a picture now, but we remeasured these in 2010, and those activity fuels based on the masticator have largely decomposed, and they decompose much faster than I ever would have guessed. And when we look at the torching index today of the mechanical unit, the one you're looking at right there, we actually now approach the same torching index as the next picture, which is actually the treatment that uses fire. Here's one of our burns at night. You can see one of my former students, Tadashi Moody, working at night, burning a mechanical plus fire unit. And there's that same white fir tree dead center. right here, the white fir tree, and you see that fire has basically removed a lot of those activity fuels and the surface fuels that were natural. And the torching index in this model condition is extraordinarily high, greater than 500 kilometers. That's basically outside the range of these models, but it at least tells us that this is a very, very resilient forest in terms of the ability to withstand fire. But again, I'll just say that caveat, that if you look at the mechanical treatments today, mechanical treatments are actually not significantly different than these fire treatments, which continue to have excellent torching indices after that 7-year period for decomposition. A little bit surprised me. I didn't think it would decompose that quickly. So these are some of the ideas of effective fuel treatment, reducing that surface fuel, reducing ladder fuel. Crown fuels is a small piece of the game. I would estimate between 5 and 10%, the maximum, the hazard of these mixed conifer forests are in the crown fuels. Most of it's in the ladder fuels, which can be moderately sized trees certainly, and also the surface fuels. So the question becomes, what about the ecological effects of those things we just saw, those treatments that we have, mechanical treatments, burning treatments, combination treatments? So I've heard questions over the years, and people have wondered, are we causing ecological harm? Is there something that we have to give up maybe ecologically to do those types of treatments? So the question then became, can we synthesize a literature here? So what I did is just ask a few people to maybe help in a paper to try to synthesize the fire restoration, fire and fire surrogate study literature. So put together a group, and then we looked at vegetation, fuels, soils, bark beetles, carbon, forest carbon, wildlife, and then utilization. So this was published in Bioscience paper 2012. Dylan Schwilk, who now is at Texas Tech, he wrote the vegetation module of this paper. And then you can see right there in the text, although the number of exotic plants tended to increase with levels of treatment disturbance, especially mechanical plus fire, overall understory species richness also increased, especially plants that are favored by more xeric conditions. Mechanical treatments weren't complete surrogates for fire, but their application did help mitigate costs in some areas. So Dylan, looking through the research U.S.-wide, this is not just California, this is not just the western U.S., this is the entire U.S., and Dylan, doing his best job as he could, synthesized that literature and found very little harm from vegetation standpoint, and the only thing that really did cause a little bit of concern possibly is increases in non-native species after fuel treatments, and those increases tended to increase further when you did more removal of overstory and also burn the ground. But still, not huge differences, but yes, they were something that we all would maybe want to consider. So the next area that we actually did a synthesis was soils. Ralph Borner, he wrote this area of the soil synthesis for fuel treatments, and he found out that mineral soil, pH, exchangeable cations all responded to treatment for the short term. However, they were really ephemeral changes. They didn't last a long time, maybe 3 to 5 years. Other soil variables, bulk density, soil carbon, deadwood carbon, soil nitrogen, he said exhibited very small responses or no measurable treatment response at all. So from Ralph's synthesis of the soil literature and fuels treatment nationwide, he basically said, I see almost no evidence of soil harm. That's another interesting thing. Didn't see much evidence at all. The wildlife. Now the wildlife, we have to remember, the wildlife we're talking about is stand-level animals. These are small mammals, nesting birds, a few reptiles. The reptiles are actually very, very rare, so we really couldn't say much about them at all. But this is basically groups of animals that are living in stands. We're not talking about Northern California spotted owls or Pacific fishers. They're basically home rangers or outside of this analysis. But Pat Kennedy and Joe Fontaine did an analysis on the ecological impacts to wildlife and fuel treatment. And here's a summary. Wildlife literature dominated by studies in birds and small animals demonstrate short-term and at the stand scale fire surrogate forest thinning treatments effectively mimic low-severity fire. However, low-severity fire is not a substitute for high-severity fire. There's certainly some differences there in terms of habitat. So again, another nice synthesis showing that at least for the animals studied here from the meta-analysis presented, we see very little evidence of harm. Bark beetles, this is Chris Fettig from the Forest Service PSW station. Chris basically said that beetles do increase after fire, and this is pretty routine. And most of the increased mortality actually is in relatively small trees. But we also know snags are important for part of forests. In the longer term, though, it looks like the thinning effect actually had a benefit to reduce the vulnerability of insect attack. So nothing here also very negative. And Bruce Hart, so utilization. He actually did an analysis of utilization, which is very important, certainly. He talked about promising efforts to reduce costs through processing and handling of materials in bulk. And it's more expensive even today to think about chips and biomass compared to things like coal and oil. And things like transport distances were key. A lot of you all know this. And again, from utilization standpoint, I think Bruce showed us that there are really also some benefits there, but also some challenges. So the summary of the effects. The summary of the effects, in my view, based on the paper and the co-authors, is fire and fire surrogate treatments are causing very little negative impacts. If anything, they're probably causing positive impacts. I see very little evidence here that doing these types of treatments in forests that used to burn frequently under low to moderate severity fire regimes are causing harm at all. I think the paper does a pretty good job with that, and I think that it's something we can basically, say, okay, we can move on a little bit. We're not causing too much harm. Again, the caveat again is, this is not talking about California spotted owls, Pacific fishers, and some of these other animals that have larger home ranges. We don't have this type of research replicated, multiple sites that actually I think allows us maybe to make those inferences. Let's move on here. So, can you do fire hazard reduction and restoration at the same time? Yes, you can. I think you can basically do some things that are integral to meet both. We know that the fire hazard side, frankly, is easier. It's surface fuels, ladder fuels, reducing those to points where we don't have the ability to move fire. The restoration piece is tougher because we don't have as many tools that can focus in on those absolute integral pieces, but can we use some information maybe from other places in California to help us understand restoration? And here's a place, it's Illilouette Creek Basin. This is another place where Brandon Collins has been the lead. There's Yosemite National Park, and you can see down here about the center, we see this is Illilouette. Illilouette Basin's this little perimeter I just highlighted with the little green arrow. This is an area that has had a lot of managed wildfire, and here's a picture of the managed wildfires that have been burning in Illilouette since 1974. Very little suppression, almost no suppression, lightning fire allowing to burn an upper mixed conifer. We're talking about Jeffrey pine, white fir, lodgepole pine, little red fir, a little higher elevation than typical mixed conifer. Here we got a fire, the Hoover fire burns in 2001, lightning fire that burned a lot of the Hoover area, pretty high severity conditions in terms of wind. And then these two pictures try to show us essentially on the left side are limited fires where a new fire runs into one that burns maybe 7 years, 1 year ago, 5 years ago. You see the numbers there. They're putting themselves out. They're self-limited because there's no suppression, but just the fuel discontinuity of the more recent fires is limiting fire spread. On the right side, you see other fires interacting with previously burned areas, 24 years, 23 years, 13 years, 30. Here we see evidence that the fires are burning right over the top of the previous. We're not seeing much evidence of limitation. And this probably makes a little sense as the change forest structures happen. So we look at a bunch of variables here to try to come up with an idea of can we predict what's the important part of this limitation or the reburn? And Brandon comes up with these two figures. They're both in an ecosystems paper he publishes in 2009. Let's take a look on the right side. The right side one is the information is a little bit more obvious. So over here we got a tree. On top of the tree is time since previous fire. So on the left side we see less than 9 years, and on the right side greater than or equal to 9. So on the less than 9 years, we see that we have evidence of 10 fires that basically all limit themselves. They go out on their own, and the number of reburn fires is 0. On the right side, when the previous interval is greater than 9 years, we have a burning index. The burning index is a National Fire Danger Rating System index. If it's below 35 or above 35, we get a split. If it's below, we get 4 reburn and 4 extent limited. On the right side, if it's actually above 35, fire weather a little more extreme, we get 12 reburn fires. So this is a nice statistical analysis to show that if you're under 10 years or so, there's a really good chance that the fire is going to be self-limiting, but as you actually increase the years since the last fire, fire weather is also going to have an input and actually cause impact. One thing about this picture I think that gets people a little excited, unfortunately, it doesn't say how many times has it burned in the last 30 or 40 years. That actually was one of the variables that was in there, because some places in Illilouette have actually burned 4 or 5 times since 1974. They've burned that many times. I thought maybe that if a place had burned 3 times, say since 1975, that somehow maybe it would have a condition that would allow it to go further into the future and still maintain that, really that resilience or its capacity to mitigate fire spread. Well, it turned out that was completely wrong. You see in the little picture there on the right side, it doesn't say how many times has it burned in the last 35 years. It tells you how many times has it burned lately. So it says 9 or 10 years is kind of a break point. So unfortunately, it kind of tells us that instead of having the ability to kind of have multiple fires for a while, then kind of take a rest, this little figure tells us, well, you got to have fire on this site every 10 years or so, 10, 12, 15 years, and that then produces this self-regulating network. That's a lot of fire, certainly, for a lot of places, isn't it? Thinking about having a fire every decade, my goodness, that's a lot of fire. But the analysis here tries to show that that's really an integral part of this landscape. Well, some of you have certainly heard me talk about Mexico, the Sierra San Pedro Martir, and I just want to talk a moment about that. This is a place in northern Baja. It gets around 20 inches of rain a year. Precipitation level record is really limited. It's granite parent material. Where's it at? Here's a little picture. You can see the red diamond. That's where the Sierra San Pedro Martir is. It's a southern terminus of the peninsular mountain ranges, which actually include the Cleveland and part of the San Bernardino National Forest, like the San Jacinto Mountains. This is the same mountain range. It runs north-south, goes through the international border. It ends down here at the Sierra San Pedro Martir. What's it look like? Well, here's a picture in the winter. This is actually a friend of mine. I didn't take this picture, but it does snow down there periodically. The last El Nino, the big El Nino, 97, 98, they had 2.3 meters of snow here. That's a wet year. Typically, you don't get that kind of snow load, but it's high elevation, so it does get some snow. Forests down there are basically Jeffrey pine mixed conifer. The neat thing about the Martir is fire suppression doesn't begin until 1970 when they build the first road, and harvesting has been very, very low. There's like one area of 20 acres that they did some thinning from, and maybe some commercial harvesting. They did do some commercial harvesting, but 20 acres out of 40,000 is pretty tiny. So I argue this is one of the last relatively intact Mediterranean forest ecosystems really in the world. If you look at any Mediterranean climate in the world, you don't really find many forests that are relatively intact. And the Martir, I would argue, is one that has fewer management inputs. It's been grazed. By no means is it pristine, but it does have some character of kind of what forests used to be. A couple pictures here. You can see to the left side, Jeffrey pine, big ones. Diorite granite in the background. Salvia in the immediate dead center. And then to the right corner, there's a greenleaf manzanita. So when you're standing there, it feels like you're in the eastern Sierra Nevada, maybe the eastern Lake Tahoe Basin, or you're in the San Bernardino Mountains or in the San Jacinto Mountains. It feels like you're somewhere you're very familiar with, but alas, you're down here in southern, or you're in the northern Baja California, Mexico. Site productivity is not very high, but still a very typical east side pine type. I think very typical in terms of what it is. Now, what have we learned about the Martir? We've been down there about 13 years or so. We put in a bunch of data plots. We tried to measure mortality. And one thing I want to talk about just for a moment is this notion of forest structure. And we all know that snags are important. Snags are important for wildlife. They're important for insects, a lot of things. If you go down to the Martir and you start to measure snags and plots, you find out there's no snags in about a quarter of the plots. The average density of snags in the Sierra San Pedro Martir, interestingly, is about 2 snags per acre, which I think is actually, some people talk about that as desirable in a lot of places in California. But the less than average density of snags of 2 per acre occur on 2/3 of the plots. Greater than 4 snags an acre, about 15% of the plots. What's the conclusion? The average densities of 2 per acre are rare. They happen about 12% of the time. Well, let's go to another category. What about fuel? These are surface fuels. The average fuel load down the Sierra San Pedro Martir is around 6 tons an acre. It's pretty darn light. But it turns out the average load of 6 tons per acre, we only find less than that. We find less than the average load in 73% of the plots, greater than 8 tons, about a quarter of the plots, and 16 tons, about 8%. So what's that tell us? The average fuel loads are rare, 15% of the area. So you have potentially small areas with high fuel loads, but not many areas that have very, very common average conditions. What about regeneration? Here's a little slide in regen. Patches, number of regeneration patches per acre, things of that nature. Turns out the regeneration is very episodic. It's not continuous. And we see a lot of variation in the amount of area with regeneration. Forest canopy cover, you can see maybe there in the dead center, averages 26%, and it varies between 0 and 56. Remarkably similar to what we saw in 1911 we talked about a moment ago. So this is the thing about, I think, the Martir. The Martir tells me flat out that if you're trying to manage for forest and you're trying to generate average conditions at the stand level repeated over watersheds and landscape scale, that it basically cannot be found in these forests like the martyr that are relatively intact. The martyr has great variation, incredibly amount of heterogeneity. And the idea that we want to manage for average conditions of basal area, average snag density, average dead and down log density, the idea we want these average numbers, and by the way, we want them on every acre that we're managing, we can't find those things in the Sierra Symphasia martyr. I would call that ludicrous, okay, my view. So the idea of average conditions, you can find even the martyr about 15% of the time, 85% something else. So that tells me that average condition management is something that I get real nervous about. What about a wildfire? Well, I know we're running out of time a little bit. We're okay, but I wanted to talk about wildfire. It happens in 2003, right after a severe drought. We're talking about a major drought in this part of the world. Maybe some of you in the San Bernardino, San Jacinto Mountains. There was great mortality that occurred down there. In fact, it's one of the congressional inquiries that I got to testify at. Congress got involved in this. This is a big drought, mediated bark beetle impacts, and then we had a fire. Look at that picture. That fire, that area you see in that picture, was all burned in the 2003 wildfire, the Sierra Symphasia martyr. It has some dead trees. You can see a few in there, but you can see an awful lot of green trees too. And this actually happens after 4 years of severe drought, and it burns in a wildfire. We're talking about major stress. Here's another area. You can see in the foreground some shrubs have been top killed by the fire in 2003, but the background we see some patches of trees alive, some areas of shrubs have been burned out. What's it tells us? Well, the martyr tells us after the 2003 wildfire, 20% of the trees died. Think about that for a minute. 4 years of drought causes Congress to get involved to the San Bernardino side with very little fire at all, and then this place burns in a wildfire. If this had been the Lake Tahoe Basin, there would have been senators piled on top of each other. This place basically had the severe drought, burns in a wildfire, 2003, and only 20% of the trees die. The martyr is the most resilient forest I've ever seen in my life. The resiliency is uncanny. This is something that I think that we want to maybe generate in our forest, and I think one piece of that is spatial heterogeneity. Heterogeneity in these systems does not allow things like insects, disease, and fire to move very, very quickly, a lot of discontinuities, and mortality can then be low after these types of issues. That's what the martyr has told me. Martyr tells me, don't manage for average conditions on every bloody acre. That's exactly what this is telling us. Here's a little picture from Malcolm North wrote a paper on synthesizing information on Sierra Nevada, the GTR you see over there in the right-hand corner. And I think he's done a nice job. I was part of this, Kevin O'Hara, certainly other Peter Stein and Bill Zielinski. So we're talking about trying to think about some ideas of restoration. More heterogeneity, I think, is one that actually is done very nicely in this GTR. Here's a picture of data from a paper that came out in Journal of Forestry recently. Malcolm North was the lead author on this. I don't want to spend a lot of time on the data on the table, but look on the left side. The left side tells us what the Forest Service is doing today. Mechanical treatments around 28,000, prescribed fire treatments in the Sierra Nevada about 8,000, and wildfires burning around 51,000 acres a year on average. That gives you a grand total of around 88,000. 88,000, remember that includes all the wildfire acres, and I wouldn't call all those wildfire acres restoration. Maybe half of them, maybe 40%, I actually don't know, but it's certainly not all of them. But if you look at this data, the 88,000 acres a year is around 18% of the area that we think maybe got burned in some capacity pre-1800. So that tells us something. 88,000 acres a year, about 18%. So the next question becomes, what are we doing today in terms of a graphic? And here's a graphic from the Journal of Forestry paper. This one really got me going. So here we see on the left side, that's the current level of treatment that includes all wildfire, all mechanical treatments, all prescribed fire treatments. There it is, okay, down there on the bottom. And then the next little column shows us what we think maybe used to occur historically. This is basically at historic levels based on forest type that's coded by color. And then the right one, there's the big giant one. The right one, Malcolm talks about as backlog. This is incredible. What this tells us is at the current rate of wildfire and treatment in the Sierra Nevada, that about 60% of the area in Forest Service acreage in the Sierra Nevada will never be burned by wildfire or will not be treated by any means. So it's almost like a constant backlog. It's just going to be continue to have fire suppression and very little change. Can you imagine that? Thinking about forests into the future and 60% of the fire-dependent forests in the Sierra Nevada going forward in a warming climate with all these issues, and we got 60% on the table that basically are not going to be treated at all based on the current conditions. That just gets me a little excited because I just think that that's not where we want the forest to be in our next generation of people. I think that just gives too much hazard. So my last slide. So I think that high amounts of spatial variation is incredibly important. I think that's something I know a lot of you are already thinking about out there. I know I've gone to field trips, talked to many of you. This is getting implemented. I'm very excited about that. I think more managed wildfire is a good thing. I don't think the idea of going pure managed fire, which maybe is something the Park Service and Forest Service is thinking more and more about. I still think treatments with prescribed burning mechanical methods are really important. I don't like the idea of all of a sudden just saying we're going to go to pure managed fire because of budgetary reasons primarily. That's my view. And then the other thing is the idea of restoration and also fire hazards. We looked at the data for a minute that there's no evidence that we're causing ecological harm based on the literature when we do fuel reduction treatments. I just see, that's a pretty good literature. It's pretty robust. You can take a look at that bioscience paper. I see very little evidence. Again, if you're thinking about organisms that work at bigger spatial scales like California spotted owls and such, unfortunately, we don't have data to conclusively talk about that. And at the bottom, I think I'm actually somewhat optimistic. I know that many of you are working on land management plans and revisions. I know the Forest Service is going through an exercise now, starting to think about revising their forest plans. Hasn't been done mostly since the 80s. I think this next 3 decades, next 30 years or so, absolutely critical as a time where more innovation, new ideas could be created, and some ideas to try to think about those landscapes out into the future. How do we increase the resiliency? How can we do maybe restoration and fire hazard reduction together? How can we manage wildfire possibly? I know all these are huge issues, but I do think about the next 1 to 30 years, next few decades, as this being integral. Can you imagine? I got worked up the other day thinking about what kind of legacy are we leaving the managers of these lands, say in the next 50 years? What about our grandkids or something like that? Are we going to give options for our grandkids to actually exercise, say in 2000, we're out 50 years from now, 100 years from now? I think it really is on us to think about ways to increase that resiliency. We know warmer temperatures are coming. We know we're going to have more stressful environments. What can we do today possibly to think about setting those systems up in the future for more capacity to managers to make decisions versus just trying to react at the next disaster? Okay. Well, here's an acknowledgement. My papers are all available on my website. You can get them as PDFs. And I just want to thank some of my colleagues, Malcolm, Brandon, Carl Skinner, Danny Fry, and several other folks. And I think that's it for me. I hope I didn't talk too fast.
Well, thanks a lot, Scott. A lot of information there, and people have certainly been raising a lot of questions, and we'll drag the kinds of questions that have come in over. So we'll start posing these to you, Scott, and what we'll do at the very end is we will have Susie talk about some of the web links and such that are available. So let's see. Susie, should I drag those in? Are they there? Okay, the very first question that came in, Scott, you can see it right there in front of you, was 1911 after the forests, you made that as a reference point, was that after the forests were already cut for railroad and city building in California? So
this area turned out to be there was no harvesting at all. There was none ever recorded, and certainly you're right, there was railroad logging coming in there soon, but the areas that we actually were able to inventory to date, we had no evidence of that. I think it was actually done to try to set up more information for the early harvest. So we don't see any evidence at all of harvesting in these systems in 1911.
Okay. Next one is quite similar. I think this reference year of 1911, Steve asked us, how does this compare to the estimates of 1800 conditions?
Yeah, I've seen some of that 1800 numbers. I actually have done a little work on that too with things like Sudworth and others, and I think that the data that I've seen from the maybe other early inventories, I think a little bit more biased. I actually wrote that in Sudworth. I think Sudworth was going around and maybe chasing more of the timber stands with a little higher volumes. The nice thing about 1911 is I think we argue that it's an unbiased inventory. Includes low density, high density, landscape perspective. So I think the 1911 data, as far as I know, is actually the only unbiased data that I know at large scales for forest inventory. The amazing thing is we have evidence that every national forest did this in California, right around the same time, about 1909, 1913, but we only can find the original records like the picture I showed you from the Stanislaus. The National Archive in San Bruno has actual summary records for all the national forests, but they do not have the data on the original records actually recorded, so you can go back and remeasure. So this seems to be something that was done Region 5-wide.
Okay, good, Scott. Brent asked the question, do you have a torching index on brush pile and burn as opposed to floor burning? And you referenced the work at Blodgett with the underburning. I don't know if you have a comparison or seat of the pan estimate on brush pile and burn as opposed to underburning.
I think you would still be quite effective. You wouldn't get all the natural surface fuels out, but you certainly can get the activities and maybe some of the larger natural fuels out. I still think that could be very effective in a lot of treatments. You could probably easily get double what we had in mechanical treatment. I think we had something on the order of maybe 50 kilometers an hour. I think with a pile burn and maybe a raking, you could easily get up to maybe 120 or so, 100. So I do think that is something that has benefits in a lot of areas. You could really mitigate fire hazard with a brush pile and burn.
So from the Sierra Valley RCD, we had a question. What is the torch index range that you would do prescribed fires in to reduce things getting out of hand? How do you, and then the sort of a technical question for us non-fire types, how do you determine torching index?
Yep, a torching index is actually it's an output you can generate with both Nexus Fire Behavior Program and also called FMA Plus, Fuel Management Analyst. What it tries to do is most fire behavior that looks at crown fire tries to tell you how fast a fire is going to propagate crown fire. What this does actually is solves the wind equation. So it says, okay, if you're going to have a crown fire, what wind do you need in theory to generate that crown fire in that ecosystem? So it really is kind of the threshold wind that you may need to actually get that crown fire potential. It's a nice way to maybe measure the potential for an ecosystem or a forest to have some sort of harm. And the idea of conditions for burning are going to be even below that, way below. We're talking about, many of you are doing a lot of prescribed fires out there. Temperatures, humidity, relative humidity being so important. I've done prescribed burning in the Sierra Nevada and elsewhere. You're looking for RHs, relative humidity above 40%, maybe temperatures down in the 60s, wind speed to be relatively stable, and certainly you don't like to have big changes like fronts coming at you. So there's a lot of conditions, certainly, I think, that allow burning. And burning at night. We did most of our burning. You saw that picture from Tadashi. We did a lot of burning at night. I think burning at night turns out to be an awesome opportunity. I know logistically it can be a challenge for some, but I think burning at night is actually another opportunity.
We promised people a 1 o'clock break time, so we're going to take a brief hiatus from the Q&A. Scott had indicated he can stay for a little bit after 1 to keep answering questions, but I'm going to turn it back over to Susie to talk a little bit about logistics for the next workshop and any follow-up on logistics, and then we'll come back to the questions. There's still quite a few here, and Scott will go at it for about another 10 or 15 minutes. So, Susie?
Thanks, Rick. Yes, I just wanted to let everyone know about upcoming webinars. You can see, and later we'll move our notepad out of the way, but the next one is February 25th. There's one registration site that's listed there. That's a presentation, so you can't actually live click, but if you look in the lower left-hand corner of your web open window, you'll see live web links. So there is the webinar homepage where the papers that Scott mentioned, if they're in the public domain, are posted, and if not, there's a link to Scott's website, as well as a research brief from the California Fire Science Consortium that you can use to follow up on what he talked about. Please take our online evaluation survey. There's a link there, the second link. Scott's homepage is the third link, and then the California Fire Science Consortium homepage is also listed, where you can get quite a number of research briefs and other information on current fire science in California. And the way that those links work is you highlight it, and then you click the Browse To button. And for me, it opens another web browser, and when I close out of the webinar, I see those windows. That's how it works on my computer. So thanks, and I will turn it back over to Rick and Scott.
Yeah, and I think Susie will also be sending out the link for the recording, and we might also, in that email that comes out with the link to the recording, reference those web links as well, so you can follow up on your own. So just another possibility for you. Carol up in Trinity County asked the question, how do steep slopes affect this torching index? So you're getting a real chance to demonstrate your knowledge of torching index there, Scott. So do you need to remove more fuel load on the steep slopes?
Yeah, you're right, Carol, that torching index is really going to be impacted by slope. And actually, those two models, the Nexus and also FMA Plus Fuel Management Analyst, Don Carlton wrote that model. Both of those are actually include the slope as part of the calculation of torching index. And you're right, if you're going to try to maintain maybe resiliency in those slopes, it's going to be more fuel reduction is going to be in line, where you have less surface fuel, less ladder fuels, and that slope is going to have to be accounted for. So yes, torching index and that type of fire moving up a slope will much more ability to do so, and you're right, you would have to do more reduction, and that certainly is an issue because as maybe you're alluding to, if you've got steep slopes, you can't get machines on them very effectively, what can you do? It does become much more challenging to think of those areas and how you're going to manage them because of the inability to get machines.
Brent asked the question, estimates of per acre cost for the mechanical treatment. You referenced the rotary mastication and the fire and fire surrogate in your slides there. Do you have any estimates of that? Or?
We sure do. Bruce Hartsoe did that, Bruce UC Davis. It turns out that the rotary masticator is quite expensive to run. We actually estimated about $400 to $500 per acre. That machine running with an operator, a good operator, full day would only do 2 to 2.5 acres per day in that heavy mixed conifer forest at Blodgett, 2 acres a day. So I think it's actually a treatment that's applicable to some areas. I can't imagine it being applicable to huge areas because of just the cost of it and also the access and also just how many masticators can you get to run. I've seen a lot of people use these in plantation management. Seems very effective there. But at least the treatment that we applied, about $500 an acre, was actually the cost.
Okay, good. Don asked the question, the treatment effects with air quality. That really didn't come up in your presentation, and it's certainly a major issue, and the effects on human health impacts. Do you have any thoughts about that, especially with the large acreages that historically burned and the comparisons? Do you have any thoughts on that topic?
Well, Don, you bring up a great point. I mean, that is probably one of the biggest issues in the room is smoke management and the ability to do work that tries not to impact people, especially folks that have illnesses, asthma, and others. So this idea of, that we talked about, kind of the prehistoric 6 million acres a year, I think that has no chance of ever coming back. I don't think it's desirable in any way because the impacts to people, communities, would just be overwhelming. I just think that it just gives us an idea of a context of just how much disturbance and how much that disturbance was such an integral part of our ecosystems, then I think that just enables us maybe to think about trying to do methods such as burning, such as mechanical, such as combinations that allow us to think about resiliency into the future. But you're right, smoke management is integrally part of this. It's huge. But I also would say that I have to argue a little bit for the fire side that I think it still has to be a piece. But smoke management is huge, and other methods are certainly applicable. I know some folks would argue to me, and they still do today, that it's all got to be fire. We got to do all this with burning. It's the only natural thing. And others might argue that we got to do it all with mechanical. Mechanical is the only way we can do it. We can regenerate some products, sell them, things like that. I always say you try to do everything that makes sense at your locality, but you don't try to take things out of people's toolboxes and ability to make choices. Let the local manager try to do the best they can based on the conditions.
Okay, good. Our friend Don Gasser, the other Don the second, 2 Dons in a row, talked about this question of timing of fires and the effect of timing and severity are interrelated, and raised a question. Undoubtedly, these timing effects are hard to measure after the fact, or not. And you might talk a little bit about how some of these historical studies can or can't get at the timing of fires.
Well, you're right, Don. I mean, the timing of the fire is kind of the longer-term view. At least if we talk about the surrogate study, we talked about how we did treatments in 2002, and we actually did a reburn of the mechanical of the fire units in 2010. I didn't talk about that at all, but we did do a second entry of fire into those units, and then then I mentioned how the mechanically treated units actually had already gone through decomposition at a much faster rate than I ever would have imagined. So I think this idea of a longer term, or kind of you're looking out for scheduling and getting, looking out for many years, I think combinations of treatments like maybe mechanical, maybe you follow it 10, 12 years later with a burn, you have much less smoke because a lot of that stuff is decomposed already. It'd even be better if you could take it to a biomass facility and remove the activity fuels. That way you wouldn't have to burn those activity fuels. You can maybe use them. So I think this idea of timing and kind of the portfolio for the future, again, is going to be a little bit locally defined based on options, but it is also integral. I mean, how do you set something up maybe in sequence that you can meet your objectives into the future? And I think that there are options to do that.
Another question from Sierra Valley about some of your references to this martyr. And you can see the question there. 26% was the average with a range from 0 to 56.
Yeah.
How characteristic is that to California conditions, or is it a pretty big stretch to go from northern Baja to California?
Well, this is a great question, and I think I would believe that those numbers we chatted about for the martyr, I would say east side pine type. If you're an east side pine type, if you're looking at ponderosa pine, Jeffrey pine, precipitation probably on the order of maybe 18 to 25 inches. Eastern Lake Tahoe Basin. I think all those systems actually have incredible character similarities to the martyr. One thing, the martyr is a little different. There's the lightning fires in the martyr actually occur mostly in June and July, so earlier season of fire versus actually in the California where we have more late season fire. So there's a seasonality of fire difference. But I think when we think of eastern Sierra Nevada, the drier pine types, many of those types, as we saw in that picture I showed you from the guard station, have gone from pine type to maybe mixed conifer or some other combination thereof because of the last 100 years. But I think the conditions that the martyr shows us are very applicable to those systems. They're not applicable to the west side mixed conifer, ponderosa pine, Jeffrey pine, incense cedar, white fir, the places that are prime mixed conifer. I really wouldn't go there with them. But the east side types in California, I think they're very similar.
Another question about sort of the art of prescribed burning. Why aren't we training more people to burn? Scott, you might say a little bit about the new Prescribed Burn Association. And as I looked at the members on this webinar, we have a number of members of it that are signed on. You might say a little bit about that.
Sure. Yeah, Don asked a question about training prescribed burn people. And as Rick just alluded to, there's a Northern California Prescribed Fire Council, which actually is headed out of Redding. A really interesting group that's been up now probably about 4 or 5 years, really starting to get people together for meetings once or twice a year, facilitating workshops. I think a very, very powerful idea. And actually, there's a new Prescribed Fire Council that's just beginning to get created, almost done now, the Southern Sierra Prescribed Fire Council, which is Lake Tahoe all the way south through the Sierra Nevada. And Tim Klein on the consortium, California Fire Science Consortium, could actually maybe connect you to some of those folks. So I think in some ways it's things like that, more ideas to maybe work together, understanding some of the limitations and the challenges and also opportunities. And this is going to be a part of kind of federal land management. Many of the prescribed burners that are really awesome experts had dozens of years, 20, 30 years treatment effects on local land. A lot of those folks are retiring. And there is a concern. I've talked to a lot of federal folks that are wondering how that knowledge is going to be transferred to the next cohort. Forest Service and others, there isn't a lot of folks in maybe mid-career. There's a lot of people in the older career, some on the younger career side. So I think that's also a piece of it, just trying to get that legacy of information from one person to another. I think that's actually crucial.
Okay. Next question from our friend Glenn Nader in the Central Sierra, referencing this huge backlog that you talked about in your talks, Scott. How do we change the fuel loads with the high